a loss of 400,000, and a return of negative 404%. I don't even know how that's possible. What's up, guys? Coding Jesus here. Guys, a couple of weeks back, I sent a message on my community asking for code that I can review. Now, naturally, being a more finance-y related channel, I decided to review finance-y related code, and that is a backtesting engine. Let's take a look first, without looking at the code or any of the files. Let's actually take a look at the structure. As you can see here, we have source and examples. Something immediately is off to me. There's no include directory. Now, if we have both source and examples, and the examples build off the source files, why is there no library that the examples can target and link against? Why is there no include directory that would serve that exact purpose? In C++, you have source files and you have header files. And if I want to include those declarations or that library that I build inside my examples or my tests, I need a separate include directory to make that distinction very obvious. So taking a look at the CMake list here, for example, everything's handwritten. I think everything up to here was fine, but now we have a bunch of handwritten CPP files, a bunch of include directories, and what's really strange is we have an executable here, but we don't have a main method. Nothing here in backtest engine or data or indicator or strategy has a main method. So we're building an executable that says, assuming you have a main CPP in the root directory, why would we even include this here if there is no main CPP in the root directory? So we also have here another add executable for a project that's in the examples folder. And this is kind of like an integration test. So it's an implementation of his backtesting engine. Now, what's ridiculous about this to me is that this was written 9 months ago, and this person enthusiastically submitted this code for me to look at, but it doesn't even build. So like, what's going on in your head when you do something like that? I'm trying to think if I was an employer and I told somebody to build a project for me and they're like, here, it's done, and they send it to me and it doesn't build. And you know how long it takes to figure out that this doesn't build? What was that, 5 seconds? So to me, as a code reviewer, it's a bit disrespectful when somebody wants me to spend half an hour reviewing their code or more, because I did fix all of this so that you guys can see how all this would work. But you submit it and you didn't even take 5 seconds to make sure that it builds. Like, to me, that's a slap in the face and that's disrespectful. But regardless, it's content, so we're going to continue. So as you can see here, redefinition. So what's the deal here? So to figure this out, it's telling us backtest engine .h, the first line. So let's go into our source. Let's close examples. Backtest engine. This H should be in an include directory, which we'll get to in a second. But as you can see here, he included the CPP file. So he included the implementation of data in a header. So all that text is being copied over again into another separate translation unit, and then it's being compiled, and that breaks the one definition rule. So we have this being included twice. If you took 5 seconds to submit to build your own project before submitting it to me, you know you'd probably want something like this instead. And now we're going to make it again. But now there's another issue. Undefined reference to main. Where is main? Main doesn't exist. I don't know why main doesn't exist if you added this as an executable, but to just get over this hump, to get over this error, let's just create a main.cpp, and let's just say, now instead of having a CMake, because you're going to need nested CMakes in here, which I'll show you guys in a second, to build this main CPP, I got some bootleg instructions. But if we go into here, as you can see, you don't want to be including your library-related data like this. You don't want these relative paths. That's not how you build C++ applications. Maybe in other languages this is fine, but this is definitely not fine in C++. So it said it built a target support resistance example. Let's see, all the way at the top there. So let's go ahead and run it. Could not open file core dump. So what's going on? There's a clear general lack of care. All right, now why am I showing you all this? The fact that it's not building, because I got it to build, and I'm going to show you how I did that, and then we'll take a look at the code so you guys will understand how this person built the backtesting engine and then what the actual issues with the backtesting engine are. So let's go ahead and check out my branch. Cool. Now we're on my branch. So let's take a look at my CMake list. Now I know CMake isn't the sexiest thing to talk about, so we won't spend too much time on it, but I want to show you the difference. Everything here is kept the same. Here I just added some compiler options, and now instead of handwriting every file, which imagine you have 1,000 files, who wants to do that? Just write a glob for it. Glob the CPP files, and then put your includes that need to be publicly available for other libraries or tests in an include directory. Then add the include directory so you can reference it in your CPP files, which we'll take a look at a second. And now I added a library. I added the contents of this source folder as a library because we're going to need to add it to, which you'll see in a second, our examples CMake. So we're going to need to link it against the project there. Then we actually build the executable because we have a main method. We just include our sources, our header files, and this is just for adding and creating the library that we're going to be using in the examples. Now let's take a look at examples. Every level has a CMake list. All this does is it forwards it to the CMake list in the support resistance directory, which is also a very simple CMake list. Add the executable, main, the CPP. Now link against the core library that we had in source and include the include directory so that it becomes available in our example code. Let's take a look at now how simple the source folder looks. There isn't 100 folders here, one source folder with all the files that we need. Let's take a look at what should be like the most basic one, which is data. Let's see, do we want to start with data? Yeah, let's start with data. So I'm going to take a look at data. Okay, data, namespace data, fine. We have our header guards, cool. We have our includes, great. We have a struct called open, high, low, close. When I think of an open, high, low, close, I think of 5 values. I don't think of vectors of values. So what this should really be is a date, an open, a high, a low, a close, maybe a volume if you want, but they're not supposed to be vectors. It's not supposed to be a contiguous store of values. Effectively, if you want to have a vector of open, high, low, close, you do open, high, low, closes. Std vector, open, high, low, close. I don't like this OHLC. It's not obvious to somebody who's not finance brained. Okay? Be as clear as you can with your data member variable names and your class names. Okay. What else here is kind of weird? Well, you have something called data feed, but it's really a CSV reader. It's a CSV reader, and you also have all these print functions on your CSV reader, and you have get, open, high, low, close, parse line, etc. What's wrong about that? Well, if you go to get open, high, low, close, what you'll notice that this person's doing is they are hard coding their columns, which we'll get to in a second, but they're reading everything from the file into this open, high, low, close. Everything's being read into it. And that's not good. Because effectively, if this was, let's just say, a backtest of 200 gigabytes worth of data stored in some CSV file, your program would explode because RAM would just run out. You'd be gone. Okay? So what you want to do is you want to take a pull approach to your data, not a push approach. You're taking a push approach, which is all the data in this file, push it into memory. What you want to do is you want to write a file iterator class, and you want to read line by line. And as you read a line, you process the line, your logic runs for that line, and a decision is or is not made as it relates to that line in the context of your backtesting engine, which we'll get to in a second. But what you're doing now is you're going like chunks in a stage. Read everything, analyze everything, spit out everything. You want to read one line, analyze one line, compute one line, make a decision on one line, if that makes sense. Let's take a look here. I see that you're not very familiar with resource acquisition is initialization. You have a file, you check if it's open, fine, but you call close explicitly. You don't need to. The destructor of input file stream will take care of that. Okay, you don't want to do that. Now, I mentioned a file iterator. I actually wrote it down in my notes. I'm just going to paste it so we can take a look at what that might look like instead of doing all that massive read. It might look something like this. Very simple. You have a file, you have a line, you take the file and you read a line at a time. This file iterator might be part of your CSV iterator class. Okay? So that's going to be important to understand, because otherwise this is not a very scalable application. Now you have a bunch of like open, high, low, close printing methods here. I'm not sure why that's relevant to being part of the data feed. At the same time, you also have strangely named parameters that should probably be const, because you're communicating the intent that the parameter is not going to change. Regardless, index is what? Is it a date? Is it a relative time? Is it how should I interpret this? Is it seconds since the start of the first piece of data in the data feed? Like, is it the line number in the data feed? I don't know what index means. So that's a little hard to tell. I would move a lot of this printing functionality into just its own separate class if you need to, or if you want a way to represent your open, high, low, close, then you can add a output stream method to it or a print method to it itself, or have a printer class that takes this in and then prints it out. What really rubbed me the wrong way here is the fact that you named your variables the same way I would name parameters. So there's no way to distinguish between this being a private data member or whether or not this is a parameter that was passed in. Because imagine this function was 100 lines. Functions shouldn't be that long, but imagine it was. I would not be able to see start and end, and I would have no idea whether open, high, low, close was passed into the function or whether it's a private data member. So there's different conventions. I would just put a underscore for all my private data members. Because this is effectively not a data feed, it's a CSV reader. What you want to do to make sure you're closed for modification but open to extension is not hard code these columns. Pass them into the constructor of the data feed or the CSV reader. And therefore, if you need to change the amount of columns later, if your quant researcher comes and gives you another column he wants you to parse, you can easily do that without making too many changes to the actual implementation of the CSV reader class. Okay, let's take a look at indicator.cpp. Now, this is where things, for me, get a little uncomfortable. What do I mean by that? Well, first of all, I can't distinguish whether data feed's private or not because your, like I mentioned, parameters have the exact same naming convention as your private members. And this is effectively, I guess, forcing you to call this. I don't know why you need to call this. You can get away with not calling this. The only time calling this to me is ever justified is when it's ambiguous as to what I'm referring to. A great example of this is actually in his constructor. Because he called his private member variable data feed the same name that he called his parameter data feed, it's not really certain what he's referring to when he's trying to set data feed to data feed. So in order to make it explicitly clear that he wants to override his private member variable called data feed with the parameter passed in called the exact same name, data feed, he has to prefix the private member variable data feed with the this pointer. Now what you have is you have a private member variable of data feed, get open, high, low, close, being passed by reference. And then you pass a vector of doubles, which could be potentially millions of doubles long, maybe even hundreds of millions. And you're making a copy of all that data. Why? So why are you making a copy? Why not do const reference? Right? It's a very, very simple thing you can do, which goes to show that you haven't really thought this through too much, or you just haven't written a lot of C++. So, okay, you have the implementation for all these, fine, EMA, okay, fine. What's weird here is you have ADX, you create all these vectors, which can potentially be millions of doubles long, and you never use them. What's ATR, ATRDX, DX minus DI? What's all this? You don't do anything with them. You just literally pass back ADX. You don't need this. This is the method effectively. Right? Why are you creating a copy of the vector to get its size? You could have just done that. And you don't need the this pointer. The this pointer is pissing me off. Okay, let's continue to take a look here. EMA, fine. MACD, fine. Signal. I'm not going to go into the detailed implementation of this. Fine, fine. You're doing your Bollinger Bands, your stochastic, fine indicator. Great, okay. Now let's move on to strategy. So let's take a look at your .h first. I always like to take a look at the interface before I take a look at the implementation. So we have, okay, a templated class here called parameters, which effectively templates the value for your key value pair here. Okay. You have a lot of these methods, get, insert, exists, remove, but you also expose the underlying data structure in a public fashion, which to me is a little strange. If you're giving API methods that are equivalent to this data method or this data member, you're probably intending to make this private and only these be public, but okay. You have your strategy, which inherits from backtest engine. I'm going to get to backtest engine in a second, but I want to take a look at strategy. So you have this templated method, which I'm not sure why. Let's take a look at this. So I'm actually going to go to the bottom of the file. Previously, you had a lot of explicit template instantiations. Like you had one for int, one for float, one for double. I don't even know why you're using templates if you're only ever needing to use one instantiation, which is double. Why are you complicating things? Just put double here, hard code double. It's not an issue. You then have your next method here, and it's clear you didn't test this because if you even had one or two basic tests for golden cross or death cross, you'd notice that your strategy is not doing what it's supposed to do. Let me show you why. What your strategy here is saying effectively, if we were anywhere in this red space, and we were previously in this, I'm colorblind, so let's pick something easy, I guess purplish space. If we moved from here to here, buy. And if we moved from, let's say time is in reverse order now, red to purple, sell. And that's fine. But the next immediate action you take is you close. So the moment you transition from purple to red, you buy. But the second later, or the unit of time later, the I+1 later, you immediately close your position because you neither have a buy signal nor a sell signal. So if this was trading on a 1 second increment, you'd buy and then you'd sell a second later, which doesn't make any sense. Here, now let's take a look at the backtesting engine. So backtest engine, like I said, I like to look at the implementation first, or sorry, the interface first and the implementation. Set balance, set commission, set slippage, set sizer. All those to me look like they make sense. Buy, sell, close, fine. Run, fine. Log, okay. Stats, okay. Next, fine. What I might do is I might have stats on my strategy, but we'll get to that later. And let's take a look at what these actually do. So set balance, now we'll take a look at the implementation. Sets how much money you can start off with, total commission, slippage, etc. But what immediately stuck out to me was, whoa, what's all this? You're just initializing a bunch of the stuff to 0 or false, which is equivalently like the 0 of Boolean. Why not just do that all here? You can do is long, false. Right? Is short, false. Why do I say this? Why do I say member initialize it? Imagine you wanted to add another constructor that takes in something else. I don't know, whatever. Okay. Imagine you wanted to do that. Well, now you're going to need to copy all this to that other constructor. Or call a delegating constructor. Which, it's just not clean. It doesn't make sense. And it can lead to unmaintainable code in the future. You have your buy. You have a method, you have, okay, fine, you have your sell method, fine. I'm not going to take a look as to like whether or not this exactly is implemented in the correct way. It does look a little strange to me that you have so much like sell, am I short, am I long? Effectively, if your quantity is negative, you're short. If your quantity is positive, you're long. So I don't understand why you have all these separate short quantity, long quantity. To me, it doesn't make much sense. Let's move to close. Same thing. I don't understand why you have these separate quantities, etc. The run is where I want to focus on. So, okay, you have your initial balance. And now you just call next. The way that I see most backtesting engines written from experience is you usually have a loop in the backtest engine. And the strategy effectively says, should I continue or should I not continue? What do I mean by that? I wrote some pseudocode. I'm just going to copy and paste it over here. Instead of having strategy inherit from backtest engine, because a strategy isn't a backtesting engine, that inheritance hierarchy doesn't make sense. I would have my strategy as probably part of my backtesting engine through composition. So I will say, while my strategy can continue, which is next, which would return a Boolean, for example, then progress, keep going. Editing CJ here, guys. In progress, you'd also pass in all relevant information as it relates to that unit of time or that interval of time, such that the strategy knows the next incremental state that it needs to make a decision based off of. And then from progress, I would effectively get what my action is. If my action is buy, and this might obviously contain a little more information, then maybe, do my initiate buy for action.quantity, right? Else, if it's sell, do whatever. At the end of this loop, when I'm done exhausting the strategy, I check if I have any open positions. If I do, I just have a close calculations to close out the end of my positions at whatever price I deem is feasible for close. Maybe it was the close of the last, the close of the last print or whatever. So these backtesting engines are usually a loop. They're not just like call next on some derived class that has an inheritance hierarchy that doesn't make sense. So I always like to look at the example to see if there's tests that allow me to reason through this project, or to see if there's some sort of integration example, and there is. Now, I don't know why there's squiggly lines here. All right, so I built target support resistance. Because I decided to add all those compiler warnings, I have a bunch of these warnings being printed here. Regardless, let's take a look at the actual project itself. So if I go into examples, support resistance, and I run it. Before I run it, I want you to see what I'm running it on. So in this person's code, he has a data folder that contains mock data. This is mock backtesting data that this person's integration tests are going to be run against. If I run it against that, the integration test results are, I have a negative balance of 300,000, a loss of 400,000, and a return of negative 404%. I don't even know how that's possible. So you took time to write tests. You had instructions on how to build them in this janky README, but could you not run them and figure out that the results don't make any sense? It's like I write a program that does 1 + 1 and the results are 5, and I say, this is great, let me submit it to CJ to review my code. If you'd like to see the buildable version of this project, I put a link to the branch in the description box below. Thanks for watching this video, guys. If you'd like to become a patron, you can do so in the link in the description box below. I try to post videos weekly. Hopefully you like this change up in the video format. Thanks for watching. Cheers.